Hi everyone, this is Morgan. This week we have our interactive advanced concept presentation for Module 6, which is on the nuclear bomb. So this week we're trying to kind of just explain why and how and what goes into a nuclear bomb, which was kind of interesting. I'm, always been very interested in World War II, and there's a lot of nuclear fission in that war, with the Hiroshima bomb as well, and explained in the video that they use that in explanation, as well as the Manhattan Project. So to explain a little more is that our components to achieve the chain reaction required for the nuclear fission is the critical uranium-235, which is target. Usually in the Hiroshima bomb it was 40%. The critical uranium of 235 projectile was 60%. This is all examples in the Hiroshima bomb. As well, you need a conventional explosive charge, which then starts the action. So those components help create the chain reaction, which then it becomes nuclear fusion. As well, what is going inside of the reaction of the nuclear fission? So when I was watching this video, it explained a lot about how the U-235 or the uranium-235 releases two neutrons when it's fission. This allows it to sustain a chain reaction, which we've been trying to explain. But the bombarding with low energy neutrons cause its nucleus to split. An emission of these extra neutrons allows initial fission to generate the chain reaction. So all this explanation of the chain reaction. So as I said before, we have two neutrons that are released, creates the fission, sustains the reaction, which bombards the low energy of the neutron and causes the split. As well, comparing uranium-238, which is our natural uranium. This is naturally found, and it doesn't have that, doesn't give off that high amount of energy compared to the U-235, which we use for nuclear fission. It's more productive in that perspective, and when filtering it out, a lot of times it becomes more pure into enriching 235 as well. But since the 238 is most abundant compared to the 235, enriching, as I said before, by a mint gaseous diffusion plant or centrifuge to occur this process. So an example in the Manhattan Project, they used so many buildings just to get that one clean and enriched uranium to create those bombs. So when you're filing out these different molecules, it's wanting to get the most pure and most energy driven molecule, so then it can become so enriched that it can just explode. So as we deal with uranium in a lot of things, as well, and other things like in fossils, we experience that. So then a lot of times lead paint is used. I know this is off of the bomb talk, but it's really quite interesting how its exposure is in a lot of different things, a lot of parts of science. So we have more the nuclear bomb and the fission and fusion, And then we have more of the chemistry of the radioactiveness of different areas. So like dinosaurs, even the people that were affected by the Hiroshima bomb, they got a lot of radioactive and sickness from it. So, you know, these bombs are very dangerous, to say the least. As well, we want to make sure that we're careful in what we use and create in product. So, thank you again for everything, and bye-bye.